Assalamualaikum to panel 1, Dr. Muhammad Zulkarnain, and also my panel 2, KS Muhammad Fairuz bin Abu Bakar. My name is Muhammad SYAHIRAN bin Muhammad PIKERI, and my supervisor name was KS Encik Amir Abdullah bin Muhammad Damanhuri. Today I would like to present to you my final year project, which is the development of control measure mechanism during selective laser sintering SLS powder handling to reduce dust exposure. In this presentation, I would like to present to you the introduction, problem statement, objective of study, scope of study, literature review, methodology, product fitting, and finally, conclusion. As for the introduction part, selective laser sintering SLS is a process where it fills nylon-based powder into a solid plastic. The SLS process begins with a chamber is heated of a high temperature of the SLS powder content. The thin powder mixture is formed on top of the screen layer by recoating blade as the laser beam begins to sintering the part into the newly formed cross section. However, the use of the nylon-based powder in SLS can cause a skin to be dryness, roughness, and the worst part will be the flaking in the skin. Besides that, it was reported by a husband at the journal of 2018. The lung will respond in numerous ways, including airway inflammation, asthma, and also the organ damage. Therefore, a fully closed chamber was designed to control the SLS powder exposure during the pouring of the powder, selecting the process, and also the transferring of the powder process. For the problem statement section, all the problem begin with the selective laser sintering procedure, which is all the procedure will be done manually. The mixing tank need to be filled up with SLS powder. Then, from the mixing tank, the powder were collected by using to the storage tank. And finally, from the storage tank, the powder was pouring into the SLS feeder chamber. All of these steps were done manually. So, the procedure can cause a lot of problem, which is can cause the powder to spread and mess up the surrounding. Furthermore, according to the rebuttal at 2019, the powder exposure can affect the respiration system, and also based on the statistics by health and safety executive, there are about 12,000 of the lung disease death. The objective of my study is to design a proper powder handling mechanism for safety enhancement during SLS powder handling process. And the second one is to fabricate a proper powder handling mechanism to reduce dust exposure during powder handling of SLS. For the scope of the study, this project mainly focused on develop a proper powder handling mechanism to control the SLS powder exposure. Therefore, this research is based on the selective laser sintering printing at SLS room at Factory 2, FTKMP, U10. The second one is the mechanism appliance were planned to be fully covered and partially covered to ease the process of manual handling during the SLS process. The third one is the material that was used were only by using an acrylic sheet that has an advantage in terms of lightweight and also have a cheaper price. The next one is the design of the fully chamber mechanism will be using a SolidWorks application program as a main engineering design software. And finally, the size of the fully chamber mechanism will be reflected based on the real size of the SLS machine during the process of the powder pouring, collecting powder, and also powder transferring. For the literature review section, there are three categories that has been studied, which is the SLS, dust emission, and finally the acrylic material. For the SLS, Kalkuni in 2015 said that the SLS is the process which solid parts were made using solidification of powder, and solid pieces layer by layer were created by projecting the surface of the powder bed with a laser or even another high beam energy. For the dust emission, exposure dust has been shown a high risk of that cause a respiratory disease such as asthma, toxic, and also interstitial lung. It's said by the Rabbiti et al. In 2019. And finally, for the acrylic material, acrylic material is known as a polymethyl methacrylate (PMMA), and this material can categorize as a transparent thermoplastic. For the methodology part, it starts with the SLS powder handling process, then goes to the equipment and material selection. After that, the SolidWorks drawing will be created, and as for that, the fabrication will go into two parts, which is the CNC laser cutting process and also the product assembly. Finally, we'll go to the product fitting. If there are any failure, it will go to the equipment and material selection once again, and if not, if it will success, then the flowchart will be end there, and the project will be success. Section, this is my Gantt chart. As for the equipment and process, there are three equipment that involved in this study, which is the powder mixing tank, storage tank, and also the SLS feeding chamber. Each of the equipment has a different function and process. For the powder mixing tank, the powder will be pouring to the mixing chamber. After that, from the output of the mixing chamber, the powder will be stored and collected to the storage tank. From the storage tank, the powder will be transferred and will be fed into the powder transferring from the storage chamber to the SLS feeder chamber. This is my mixing tank model 1. From the slide, we can see that there are the design model and also the isometric view. This mixing tank first model was based on the concept of hole, where a powder pouring will go through the hole and all other area will be covered. This is my mixing tank model 2. As we can see, this design based on the concept of a slider, where there are seven pieces of the slider that added to the design so that it can be easily controlled. For the storage tank model, this is my first model. The first model of the storage tank is based on the door click concept, where the output of the mixing tank will be connected directly to the storage tank. After that, the powder from the output will go through the hole into the storage tank. This is the storage tank model 2. As you can see, the design are the same with the mixing tank model 2. There are also 7 pieces of slider that were interpreted in this design. The 7 slider will function to be control all the area that want to be covered. The difference that this model have a smaller size. This is the SLS tank model 1. The SLS tank model 1 design was based on the concept of the hole where the powder was pouring through it. With this design, the powder was no longer exposed because all the area except the hole will be closed. Therefore, a fully closed chamber concept is interpreted in this design. This is the design of the SLS tank model 2. The SLS design model 2 were based on a sliding concept, but this is different from the other concept. The sliding idea was interpreted by laying up both sides of the model. The slider can move forward and backward. Therefore, the result and discussion, which is the product fitting. Product fitting. All of the model will be placed at each of the equipment. Mixing tank model 1 were fitting based on the pouring powder to the mixing tank process. As you can see, model 1 fit perfectly and there is no gap between model 1 and the mixing tank base. Technically, the powder exposed can be controlled because of the model 1 concept that only has one hole for the powder pouring process. The function of the acrylic sheet is it is transparent. Therefore, all of the dust exposure can be seen through it. During the mixing process, all the process can be seen and monitored. As for the product fitting at the mixing tank model 2, The advantage of the Model 2 based on the slider concept, it is enable it to be tested in any condition, either in a half open or fully open. Mixing tank Model 2 were tested by partially open the slider and pouring the powder into the mixing tank. The powder exposure in the Model 2 was fully open. It's more than the exposed powder that partially closed. This is the productivity of storage tank Model 1. The storage tank fitting was based on the quality powder from the mixing tank to the storage tank. The two hingers that placed in Model 1 product will act as a joint. Therefore, the hingers present will impact the Model 1 as a upper pieces of the model that can be lift up before the output of the mixing tank were put inside the Model 1. The powder will be transferred to the hole and the powder exposure only happen inside the storage tank. This is the storage tank Model 2. As you can see, the concept of the slider take an advantage in this model. With the 7 pieces of slider, this model can control the space more efficiently. The fitting process was conducted by place the storage tank below the output of the mixing tank. Then a pulley will be put up. As the powder flow to the tank, the exposure of the powder tank only happen inside the storage tank. This is the model of SLS tank Model 1 and Model 2. The productivity of SLS tank were based on the pouring to the feeder chamber process. However, due to the unexpected thing that caused by the COVID-19 pandemic, the LSS room at 42 FKMP cannot be accessed. Therefore, the fitting process needs to be on hold. As you can see, SLS tank Model 1 concept were idealized from the idea of hole. The concept of the hole let the powder flow to it and the spread inside the SLS tank. And also, for the SLS tank Model 2, the design concept were based on the window concept, where it can be slide forward and backward. As for the conclusion, the fully closed chamber concept will apply to each of the model. The real size model also has been designed and fabricated based on the actual size of SLS equipment process. And finally, each of the model that has been fabricated can be used in a real situation to counter the powder exposure. That's all for me. Thank you and have a nice day.